In this video, we're going to talk about rewriting quadratic functions to be in vertex form. So first, let's review vertex form. Vertex form of a quadratic is when we write g of x is equal to a times x minus h quantity squared plus k. And the reason it's called vertex form is because the coordinates h comma k would tell us the coordinates of the vertex of that parabola. So the vertex would be found by the coordinates h comma k. A is the leading coefficient, and it tells us other things about the graph, but h comma k specifically tells us the vertex. So if we're going to write equations in vertex form, what we have to do is we first have to get x to have a coefficient of 1. So if there's a coefficient besides 1, we first need to factor it out. Now when we factor it out, generally when we want to rewrite equations in vertex form, they're going to be given in standard form. And standard form might look like something like this: ax squared plus bx plus c. Let me just change that to square. Okay, so if it's in this form, this will be a little bit nicer to explain. The first thing we would want to do is factor out the leading coefficient, but only from the first two terms. So we would want to factor out the a from the x squared term and from the x term. The constant, the c, we're going to leave alone. So step one, let's see, I'm going to put it over here. Step one, factor out the coefficient of x squared from the x squared and the x terms. The x terms. Okay, so that's what we would do first. So I'm going to come over here and we'll just rewrite this as g of x equals a times x squared plus b over a x. So you do have to do this kind of awkward thing. Even if a doesn't go into b, you still have to factor a out of b. So what you would do is you would take whatever that is and divide it by a. Notice I left c alone. Notice I also left a gap here, because then what we're going to do right here inside the parentheses, if there are parentheses, if a was 1 and there are no parentheses, you can create them. We're going to complete the square. So the next step inside the parentheses, complete the square. So now complete the square. Inside, and instead of writing parentheses, I'm just going to actually just draw them inside the parentheses. Once we determine what this missing piece is, and remember how we find this missing piece, we take the coefficient of the middle term, b over a, we divide it in half, so it would be b over 2a, and then we square it. So the way we would figure out what this piece is, we do b over a divided by 2, which will put a 2 in front of the a, and then we square this. So that would be the missing piece up here. That would be, I'm just going to write it like that inside parentheses, 2 over 2a squared. But we can't just willy-nilly add a term to one side of the equation. We have to also either add it to the other side, so put it over here and say plus b over 2a quantity. Well, actually, that's not even what we added necessarily. So we need to be careful. But we have to also undo that. Now, we didn't necessarily, whatever this is, we might not have just added that. What we really added was a times this. So we need to be careful. This can be a little bit tricky, and we need to undo whatever this is by taking it away if it's positive, or if it ends up being negative, if a is negative, then we would need to add it back. That way it cancels back out, and we didn't actually change the expression at all on the right-hand side. So this really would have been b squared over 4a. So what I would want to do is I would come over here and say minus, why am I putting the 4 up there? B squared over 4a. Now again, where did I get the b squared over 4a? That's kind of an awkward thing. And when we look at examples, hopefully it'll clear it up. But it was, we added this inside the parentheses. What we really added to the entire side was a times this. So we need to undo it by subtracting that same value. That way we're adding and taking away the same value, leaving us back where we started. Then what will happen here, it's getting really awkward, is this will now be factorable. This will be x plus b over 2a squared, and then will be plus c minus b squared over 4a. This looks really awkward. Let's look at some examples. Our first example is going to be f of x equals x squared plus 6x plus 3. So this particular quadratic is written in standard form. we want to rewrite it in vertex form, and then we're going to state the vertex. So we don't need to worry about this first step of factoring out because the the leading coefficient of x squared is already 1. What we might do is we might just group these two because we don't really care about that plus 3 for the completing the square. Okay, so now this x squared plus 6x is 2/3 of a perfect square trinomial. We want to complete the square. So we have x squared plus 6x. Remember how we find that third term? Divide the 6 in half, that gives us 3, and then square the 3. So we would say plus 9. This plus 3 is here because it was part of the given equation. And now we need to undo the plus 9. I just added 9 to the right-hand side. I need to undo that. And it really was a 9 because remember, this is really going to be whatever this times the leading coefficient is. In this case, it's 1. So the way I can undo 9 is I can take away a 9. Now I'm going to write this as a perfect square. And I'm going to clean up the 3 minus 9. So then we would have f of x equals, this would be x plus 3 squared, and positive 3 and minus 9 make minus 6. Now it's written in vertex form. You can see this form looks like this form up here. And the last step is we need to state the vertex of this particular function. The vertex would be at -3, -6. Remember when it's inside parentheses, it's the opposite of what it looks like, so it's -3. When it's outside parentheses, it's the same as what it looks like, -6. Let's try another example here. This time we have h of x equals 2x squared minus 12x. You know what, I'm just going to change that ever so slightly because it's going to end up being similar to the last one, so I'm just going to change this to 16. Okay, so we have h of x equals 2x squared minus 16x. In this case, we do need to factor out the leading coefficient. So the leading coefficient is 2. I factor out the 2 from the two terms that I have, so it will give me x squared minus 8x. And notice there is no c, so we wouldn't factor it out of there anyway, even if there was a c. Notice that we did not factor out the GCF. The GCF would have been 2x. We do not factor out the GCF. We need this to be 2/3 of a perfect square trinomial, so we don't want to ever factor out an x. And really, it doesn't even matter whether 2 is the GCF or not. The 2 has to get factored out. It's always the leading coefficient. Okay, now I didn't do what I usually do, which is leave myself space. We'll do that now. Okay, so now x squared minus 8x is 2/3 of a perfect square trinomial. The third would be dividing -8 in half, which would be 4, and squaring it. So it would be -4 squared would be positive 16. Now, did I really just add 16 to this side? I did not. I really added 2 times 16 to this side. So actually I added 32 to this side. The way I can undo adding 32 is I can take away 32. So now I've undone this, what looks like a 16 but is actually a 32, by subtracting the 32. Now I can factor this. So we're going to have h of x equals 2 times x minus 4 squared minus 32. There was no cleanup since there was no c term in this example. This is in vertex form. You can compare it up here. Last step, let's just state the vertex. The vertex, remember, it's going to be opposite inside, so it'll be positive 4, same outside, negative 32.